Hi friends, welcome to my channel VLSI Gyan. In today's session, we will see how to write a Verilog code for parity generator, and we will also try to understand what is actually a parity generator. Friends, if you are watching for the first time, I request you to subscribe to my channel to get all the stuff related to VLSI. So without wasting the time, let's get started. So we will see what is parity generator. A parity generator is a combinational logic circuit that generates the parity bit in the transmitter. Basically, friends, we use this parity generator for transmission of data between receiver and transmitter and receiver. So we want to secure the data. Actually, whatever the data we are transmitting, we want to check whether it is receiving properly or not. So suppose we have a transmitter and receiver and we are sending the bits like this. So our data is in the form of suppose ones and zeros. So the number of ones you are sending to the receiver, you should know. So if the number of ones are suppose 5, so I can add one more to this and I can send it so that it is now even. It is 6. 6 is an even number. So if the receiver is receiving a even number, I can assume that the receiver has received the correct data. If the receiver is receiving an odd number, then we can think that the receiver has received a corrupted data and we can stop the processing and we can go for retransmission. So basically what we do is, if the number of ones in the bit in the transmitting data is even, and if you want to send it as an even, then you can add simply 0 to it so that the total numbers including the bit which you are adding should be an even number. Similarly, if you want to send it as an odd parity, then the numbers which you have in the data along with the number which is you are adding as a result should be an odd. The meaning is that the total numbers which we are transmitting should be even or odd, right? So here we'll see the basic definition. A parity generator. Generator is at the transmitting side. Is a combinational circuit logic that generates the parity bit in the transmitter logic. Parity bit means an extra bit which we are adding to the transmitting data, so that the total number of ones should be an either even or odd based on our system. So at the receiver side, what the receiver is doing, the receiver is checking for the parity. Hence, it is called parity checker. Again, it will check for the parity to see whether it is even or odd, and both the transmitter and the receiver will be setting a rule that they are going to send even and or odd parity. So the based on that, the receiver will check whether it is receiving the even parity or odd parity, and then it will understand whether it has received a correct data or not. So basically, as I have already explained, there are two types of parity. One is odd and the other one is even. Odd means what? The transmitting data along with the parity bit. Suppose your data is like this, number of bits are like this. So if you want to send it as an odd, so you need to count the number of ones. 1, 2, 3, 4, 5, 6, 7. So this is already in odd. So no need to add any one here. So the bit which we are going to add as a parity bit will be 0 here, right? So if you want to send it as an even, then you will be adding one more 1 to it so that the total number of ones, including the parity bit, should become even. So a odd parity refers to the total number of bits that have the value of 1 in the signal, including the parity bit. Parity bit is an extra bit which we add to the transmitting data so that the total number of ones, if it is an odd parity system, should be odd, including this bit. And even parity is just the opposite of this. The total number of 1 bits in the signal must be a positive, or we can say an even number. It should be an even number, right? So a parity bit is used for the purpose of detecting errors during the transmission of binary information. So if there is any error, if there is a change in the parity, then we can assume that the received data is not correct. A parity bit is an extra bit included with the binary message to make the number of ones either even or odd. Okay, the error is detected if the parity checked parity doesn't correspond to that one transmitted. If you are transmitting it as an even parity and you receive it as an odd parity, that means that it is having some error. Some bit has changed during the transmission and it is not correct. So friends, what we do actually here is the truth table for this. How to write the code. So before that, we will see the truth table. Suppose I have these three inputs, X, Y, and Z. I'm taking a simple example with three inputs only. So if my data is, you know that three inputs means total 8 combinations will have. So that 8 combinations I have taken. So suppose if the input is X is 0, Y is also 0, and Z is 0. And if I want to transmit it as even, if I want to transmit it as even parity, then what should I add? 0 only. So my total data which is going to be transmitted is 0, 0, 0, and 0. Okay. And if my data is suppose 0, 0, 1, one single 1 is there. So the total number of ones are here 1, but I want to transmit it as even parity. So I will add 1 to the string. So what will happen? Now the total number of ones is again even. Okay. Now similarly for the other condition 0, 1, 0. So again I have added 1. Now see here 0, 1, 1. 1, 1 even number. So no need to add another one. So here I am going to take the parity bit as 0. Similarly, for all other combinations, you can see we have written the truth table. Now, if you compare this truth table, what you will find is it is nothing but an XOR gate. Okay, it is nothing but our basic XOR gate. So this is an XOR operation taking place. So simply we can generate a parity generator using an XOR gate. So here what are my inputs? X, Y, and Z are my inputs and result is the output. So I have to write the VERILOG code according to this truth table, right? So let us see how we can do this. So as I said, this is a simple XOR gate where we have the inputs X, Y, and Z and result is our output. So writing the code is very simple because it is basic XOR gate. So module parity generator, you can name it as parity generator. List out the ports. So X, Y, Z are the input ports. Result is the output port. Okay. Now here we are going to declare the port declaration. These are the port declaration. Input X, Y, Z and output is result. Now simple XOR operation is taking place. The result X, Y, Z XOR together and the output is stored in the result, assigned to the result and module. So this is how we can write a simple parity generator code in VERILOG. Same way you can go for the XNOR, you can use the odd parity generator also you can generate. So for that you have to write the truth table, then write the code. I hope this gave you a simple understanding of what is a parity generator and how to draw the truth table for it, and based on the truth table how to write the VERILOG code for it. Friends, if you like the video, please like, share and subscribe. And if you have any queries related to VLSI field, please put your comments in the comment section. I will definitely try to work on it. Thanks for watching. Thank you.